In this video, we will be working on division using partial quotients. In this problem, we're going to be dividing 63 divided by 3. So first, we need to rewrite our problem. And in this method, we extend the line down. So it either looks like a big 7, which this can also be called, or it's also called partial quotients. And the understanding with this is that we're going to just use place value instead of just following the steps of the standard algorithm. So we want to use multiples of friendly numbers, like multiples of 10 or 100s, 1000s. So here, first we just want to know if we could do a 2 times 10, which is 20. So we have more than 20, so we're able to use a 10. Could we use a 2 times 20? Yes, we have enough, and even try to go a little bit higher with a 30. So we want to, just like we do with the algorithm, we want to teach them to get as close as possible, but it's not required. So we're going to use first a 2 times 30, so 30 goes on the outside, and we multiply, which is 60. Subtract like you do with the algorithm. You have 3 remaining, which I always tell students that whatever you have remaining has to be less than what you're dividing by. So currently we have 3 remaining, so we can still divide out another group. So now we're just using basic facts. 2 times 1 is 2. We have 1 remaining, which is less than the divisor, what we're dividing by. So then our answer to the problem is over here. It's 31 with a remainder of 1, which in 4th grade we do not need to write it as a decimal. So we just use the R for the remainder and 1. Now this is the same problem as the previous slide, except for I want to show you that this method is actually more forgiving and allows for students not to necessarily have to come up with the closest factor at first, like the standard algorithm does. So I could have, if I'm better at just using tens, I could have just done a 2 times 10, which is 20, subtract again, just like you do with the standard algorithm, 43 remain to divide. Now I have 43 divided by 2. I can do another 10. 2 times 10 is 20. Subtract, now I have 23 remaining. And again, I can do another 10. 2 times 10 is 20. With 3 remain, in the same step we had the last time. 2 times 1 is 2, with 1 remaining. So here, if we put this back into standard form, is our answer 10, 20, 30, 31, with a remainder of 1. So again, whatever students are stronger with, this does increase the number of steps, but if that's what a student is successful with, then you're still going to be able to get the same answer. In this problem, we're going to do 97 divided by 3. So I'm going to show you just 2 different approaches because not every student has to solve this problem the same way. So first we need to rewrite it, and I'm going to just go ahead and use my multiples of 10. So again, I can do a 3 times 10, which is 30. I've divided 30 out so far. I have 67 remaining. I can do another 10. 3 times 10 is 30, with 37 remaining. And again, another 3 times 10 is 30, with 7 remaining. And then 3 times 2 is 6, with 1 remaining. So my remainder is less than my divisor. So then if I add this all up, it's 10, 20, 32, with a remainder of 1. If I redo that problem again, and ideally we want students to, on the first attempt, try to get as close as they can, just to divide out as much of the number as you can at first. So I could have immediately started with the 3 times 30, which is 90, and have 7 remaining, just like the previous problem. And then here's my basic facts, a 3 times 2, which is 6, with 1 remaining. So again, we still get 32 with a remainder of 1. In this problem, we're going to divide 145 divided by 5. So first, going to rewrite the problem. And then I think of my 5 facts. So, and this doesn't have to be written out each time, but I know 5 times 10 is 50. So I can keep going up. 5 times 100 would be 500. That's too many. So I know it's going to be a multiple of 10 that I need to begin with. 5 times 20 is 100. 5 times 30 is 150. So that's too much. So I'm going to start with a 20. So 5 times 20 is 100. And I have 45 remaining. So students that are not as strong with their multiplication skills, what I have them do in class is once it's this basic fact, I just have them write their skip counts to figure out 5 times what gets you closest to 45 without going over. So we just make a list of their skip counts. And they would see that obviously we can divide 45 by 5 equally. So if they're not sure 5 times what, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 times 9 is 45. There's no remainder. So the quotient answer is 29. In this problem, we will be dividing 196 divided by 3. So again, we ask ourselves, could I do a 10? 3 times 10 is 30, so yes, I could. Could I use multiples of 100? 3 times 100 is 300, so that would be too much. So we know now we're going to be using multiples of 10. So I could use a 10, but a lot of times I'll ask, could we get closer by using another multiple of 10? Well, and I also sometimes kind of underline that for them and look at that first, just like the algorithm, the 19. So look at your 3 facts. Again, if they're not as strong on their facts, a simple list of skip counts is helpful for students. Not every student needs that. And again, I don't have them skip count any farther than 3 times 10 or whatever number you're dividing by times 10, because these are our basic facts. So here they could see that 18 is really the closest. So that would be a 3 times 6 or a 3 times 60, which is 180. Subtract. And I have 16 remaining, so again they can use that skip count list, which is helpful for a lot of struggling students, and see that I have 16, so the closest you can get to would be 15, which is 3 times 1, 2, 3, 4, 5. So 3 times 5 is 15. Subtract, you have 1 remaining. Again, it has to be less than what you're dividing by. So our quotient is 65. With a remainder of 1. In our final problem, we're going to divide 345 by 6. So I just want to show you that it doesn't always have to be as close as possible. So say I start with 6 times 30, which is 180. So I subtract, and I have 165 remaining. So I know I can't do a 30, so I'm going to do a 20 this time. So 6 times 20 is 120. And I have 45 remaining. So again, if I need that list of skip counts, I can skip count by 6 and make my list. If not, students just need to think. Again, I could do a 6 times 5 here if I'm good at my 5s and do 30. 15 remain, and then a 6 times 2, which is 12. 3 remain, so that will be my remainder since it's less than the number I'm dividing by. And then I just need to put this back together. So 30 plus 20 is 50, 55, 57 with a remainder of 3. Again, yes, I could have just done a 6 times 50 at first, but I just showed on this video that you can actually add steps and work with facts that your student is strongest with.